pretty bright. All right, let's get started. Good afternoon. Thank you for joining us. I'm Karandeep Anand, the Group Program Manager with the AppFabric engineering team. And with me, I have Wade Wegner, Technical Evangelist for the Windows Azure platform. And we're going to spend the next 60 minutes talking about how do you build very fast applications, specifically web applications in Windows Azure. A lot of the learnings that you have here do apply to Windows Server as well, but we want to focus this conversation and a lot of demos on Windows Azure. So with that, here's what we plan to cover, and we want to keep enough time for questions and answers in the end. We'll take the questions in the end. Please use the microphone when you're asking questions. We want to start by just talking about all the feedback we've been hearing, all the challenges people have seen in how do you build scalable, reliable, and highly available fast web applications in cloud. And with that context, it'll be a lot easier for us to get into why we built Azure AppFabric caching and how do you can use that in your applications as well. I'll try to keep the slides to a minimum and just use a lot of demos to really explain how you can go back and start using this today. And Wade will drive most of the demos, so hopefully I won't be talking much as well. We definitely want to share a lot more information than we did in the past because we announced yesterday the keynote that Windows Azure AppFabric caching will be commercially available in the next 30 days, hopefully by end of the month. And we'll get into some details about the sizes, the capacity, other things you need to worry about when you start using this. And so one of the other things we want to do is we recently published an article in MSDN on how to use this. And during that process, we got a chance to collate a lot of the best practices we've seen from a lot of live site deployments in Azure and using AppFabric caching. And we just want to share some of those with you so you can avoid some common pitfalls and get the maximum benefit out. So that's what the next 55, 57 odd minutes look like. And we'll hopefully keep you awake. This is the graveyard shift of public speaking. Carbs have kicked in. So I'll try to keep you awake as much as possible. So with that, before we get into the challenges, we just want to get a quick show of hands. How many of you develop for Windows Azure today?
Great.
Excellent. How many of you use some form of caching, either on server or on cloud? Wow, excellent. How many of you use AppFabric caching? Okay, a few. Great. So hopefully, next time I ask this question after the session, a lot more hands will go up. So with that context, here are the things that we typically hear when we talk to web developers building a lot of applications in Azure, which is, I want to linearly scale my web app. You design for capacity X, and the capacity goes from X to 5X to 10X to 100X. How do you keep your architecture and how do you keep your design simple so your application can linearly scale with the load as opposed to having an exponential drop or just a knee-jerk and drop right there? Tied very closely to that is most applications read some form of data. How do you keep the performance relatively static so that it doesn't vary significantly depending on which user at what time of the day is hitting the website, and regardless of how many users are concurrently connected? How do you keep the performance and the latencies predictable and in a well-bounded territory? And extending on the same vision is normally you're reading data from multiple sources. You have data mashups because it's not in a highly connected web. You're reading data from multiple places. How do you store these data mashups from multiple data repositories, some you own, some you don't own, and still serve that data out to your end users in a predictable way? The next one is specifically tied to when you're building ASP.NET applications, not just any web app. And in that context, a lot of people use session state and page output caching. How many of you actually use session state page output caching today? A few. That's good. So we've heard specific feedback on the caching scenarios for session state, which are interesting, especially when you move to a platform like Azure, where just the scale-out nature of the data center does not guarantee that you hit the same web machine or web role all the time. How do you deal with session state management and reliably serve the data to end users? And the last is, of course, you want to, there are ways to go solve these problems by, scaling out the data tier. Some of the techniques are pretty complex, and how do you avoid putting a lot of pressure data tier? One, it's expensive, and second, when you hitting a disk, you're always paying a higher penalty than you're hitting a memory or a network for that matter. So how do you reduce data pressure on the data tier without learning a lot of complex data partitioning or pulling in DBAs to do heavy optimization? So there are different ways to do it, but the one other very critical element we want to keep in mind is when you get all these benefits, you want to keep your cost model predictable. There are always n number of techniques to solve any given problem, but you want to make sure that your cost is predictable. As developers, your start time is as less as possible, so you're not worried about both startup costs as well as the cost for ongoing maintenance and management. So we'll definitely keep the context of this conversation of performance along with the other axis of the cost has to be something that is manageable and predictable, as opposed to paying a lot of money when your application becomes successful or very widely used. So these were the challenges that we had heard in the past, and based on that, we figured that one of the best ways to go solve this is using a cache tier in your application. The more scalable the caching tier is, the more scenarios and the more customer segments it can go address, which is you could have a small website, you could have extremely large web applications, and a scalable data or a distributed caching tier helps you address a lot of the data access scenarios by keeping the data in memory. And the primary benefit of cache is it's located very close to your application. So wherever your compute is sitting, be it web or be it a worker or be it any compute tier, the fact that the data in memory sits closer to your compute tier reduces both the pressure on the data tier as well as significantly improves the performance of your web application itself. And the other element, which we mentioned briefly, was it's all about what is my administration, IT pro cost overhead to it. So it's great to have a caching solution, but you need to also make sure you have a solution which is easy to use, is something that you have a predictable payment model for, and you can consume and pay for exactly what you need at any given time. So it's not that you're investing in an upfront capacity or spending a lot of administration time managing that cache tier. So with that, the other two elements which we briefly touched in the previous slide were you need to be able to quickly get started, integrate with your cloud applications, and there are different patterns that you typically use to go build these apps. And you should be able to quickly inherit the benefits of caching in any of those application patterns, specifically, of course, for the ASP.NET case of session state as well as output caching. So with these, we had the AppFabric caching out in CDP since PDC. That's where we first announced it. And since then, we've been listening to a lot of feedback. We made a bunch of other CDP refreshes. We're happy to today announce that we will have the first commercially available version of AppFabric caching to start using in production applications by end of the month. So April is target. It was announced yesterday at the keynote as well. And our goal is that we have the, thank you. We're very excited about this. We've had a lot of users using the CDP releases, and the question always been, when can I actually move this to production? So we're happy that we're there now. And of course, it's a journey. We just got started with the first version. We'll keep improving, so definitely keep the feedback going, including today. So feel free to ask questions and suggest things that you don't see today that you would love to see in the roadmap. So with that, I'm just going to stop at the slideware. And before we get any further into what it can do, why you should use it, let's just actually see an end-to-end demo. How do you get started with AppFabric caching and why it makes sense for your applications? So wait.
All right, thanks. So what I have here is an application deployed to Windows Azure, and it's a very simple store application. So I've got a product list, and every time I refresh the page, what it's doing is it's using Entity Framework to call out to SQL Azure, and I'm using a timer to actually see how long each one of these calls takes. So you can see with each refresh, it's taking somewhere between 8 and 12 milliseconds, which really isn't that bad. The challenge is that I'm just one user doing a very simple execution plan against SQL Azure that it can cache. And what we want to really see is what would we expect to see under a lot of load. And so what I'm going to do is start generating load in some background threads where it's going to really start hitting the database here. And then we'll go back and we'll start to refresh a little bit. And so what's happening is, even now I'm simulating an exercise where lots of users are hitting the site at the same time. And it's still fairly responsive, but you'll note that there is load causing some latency within the application. And so what we want to do here is introduce the caching service as a way to use a cache aside pattern where we can hit the data, well, we hit the cache first and see if the product data that we are interested in exists in the cache. If it doesn't, we'll go over to SQL Azure, we'll execute our query, and then we'll insert it into the cache so that subsequent calls, when it comes in and checks the cache, the data will be there in the cache for us. So that's what we're going to end up doing. And I'm going to walk you through the whole process from creating the cache to updating the application and deploying. So, and one thing I want to note is I'm going to use a deployment method here where I'm going to deploy directly into the multiple instances that I have running. And the reason I'm doing that is it's difficult to demonstrate the value of a network cache when you're running locally on the laptop, but your cache exists in another part of the country, because it's going to incur a lot of network latency. So I'm happy to talk to anyone about the deployment method if they're interested in, but just note that I'm going to be doing a build where it actually pushes to the cloud the updates in real time. So with that, what I'm going to do is go to our CTP portal, and that's at portal.appfabriclabs.com. I'm going to go ahead and sign in. About 2 months ago, we refreshed this to use the Silverlight Chrome that you'd expect you see in the Windows Azure developer portal. And I'm going to immediately go to the cache. Now, I already have one cache provision, but what I want to do is create a new cache. And for this demo, I'm going to use this new cache that we create. And I can do that by creating a new namespace. And let's see if MIX11 cache is available. Now, we'll check availability. It is available. For the CTP, we only have one data center that the cache is set up in. So if you want to leverage this yourself, just make sure that the web app or the worker role app that you deploy is also deployed to US South Central, or else, again, you're going to be incurring that network cost when interacting with the cache. When it's released to production, it will be available in all the data centers. Right now, also, I can specify I can choose between one of two sizes. When we get to production, there will be additional sizes as well. I'm going to go ahead and choose 128 and click OK. Now, this generally takes about 30 to 60 seconds. Hopefully, it doesn't make a liar of me, but what it's doing is actually pretty remarkable. So it's creating a cache, a distributed cache for me that I'll be able to leverage. It's setting up all the authentication and authorization on top of it so that I can communicate with it. And it's setting up the communication so that it's a network service available to me as an endpoint that I can interact with for my applications. So it's going to take a few minutes.
So you never deal with servers, you never deal with setting up a distributed machine infrastructure at all?
Yeah, so if I were to do this, let's say, with Memcached or some other distributed cache in Windows Azure, I'd have to have my own instances, deploy to those instances, start them up, manage them, maintain them. And here what we're doing is we're just activating and creating a cache.
So even with Windows Server AppFabric, for those of you familiar, you have to set up a server cluster with multiple nodes. You set up the HA using the AppFabric caching capabilities, but you still are managing the server infrastructure. One of the things we're doing with all Azure App Services is we're abstracting the infrastructure layer completely, and we manage the server farm, the server cluster with the HA, with the replication, with the hardware, so that you never have to worry about how the cache itself is deployed and managed. You just get a cache endpoint to start using. So even from Server AppFabric, this is one level higher in terms of abstraction and what you have to deal with as a developer.
All right. So thank you for filling that time. So now I've got the cache active, and no, it was very interesting. So at this point, the cache is active. It's available as an endpoint for me to consume, and you can see some of the property information over here that is specific to my app. So Karan was talking about an endpoint that's available. So this is my endpoint in which I can use to interact with the cache. The cache service still uses NetTCP and uses port 22233. And we do require an authentication token come in with the request. So I also have an authentication token that's largely generated from a token provided by the Access Control Service. So we use the Access Control Service as part of the authentication model for this. And this token right here is what will be part of the request header that I send in with each request. So now that I've got that, I'm going to step away real quick and go to my application. Let me just collapse this. So here's my caching app. And you can see here, this is where I call get products. And you can see that it's using Entity Framework. I'm doing a link query against it, getting the products back, and then returning them. And so what I want to do is replace this with a cache aside pattern where I load the data into the cache, and then from there on out, I check and grab that data from cache. The first thing I need to do, though, is update my solution so that it includes the assemblies required by the caching service. And also, I want to include some updates to my web.config file. And all of this data you can get from the portal. So for instance, I can click View Client Configuration here, and it provides all of the section information, section elements that I need within my app.config or web.config file. I can also download the SDK from the portal as well. But one thing that I've created is a NuGet package that does much of this for me. So up here on the official NuGet source, if you type Windows Azure, we should get back a caching NuGet. Go ahead and install that. And what it's done is it's installed a number of assemblies for me. Let's go ahead and zoom in a little bit. So it's installed these two caching assemblies. It's installed this distributed cache assembly and these Windows Fabric assemblies. So these are the assemblies that I would use within my application. What it's also done is updated my web config file with some of the entries that I need. So we can see here it's added a config section for data cache client. So this is a way of registering the section that's going to have all of our data cache client configuration information. And then down a little ways, you'll see here is the data cache client. Now, I need to specify some of my specific values here so that it calls out to my cache. So for this, I'm going to go back to the portal. Isn't NuGet great? Have you guys been using NuGet? I think it's fabulous. Here, let's grab it from here. Oh, I misspelled it. Okay, MIX11. Cache. Okay, well, that's fun. And then I'm going to grab my token. So it's nice I can just copy to the clipboard, come in here, and get it. All right. So with that, what I've done is I've now specified the values so that each time I call out to the caching service, it'll sign the request with the appropriate information, and it'll come here to caching. Is that the right one? Caching, yep. All right. So now that that's there, we need to make some updates to our code. So the very first thing I'm going to do is I'm going to create a static data cache factory. And the data cache factory is what we're going to use to, the data cache factory is what you create and instantiate in order to interact with the data cache service. So create my data cache factory. And the reason I create it as a private static is I don't want to have to recreate this with each post back. I want to just have this once. And so what I'll do is I'll also create a new constructor where I'll check to see if the data cache factory is null. And if it is, then I'll create a new instance of it. And the reason is it's a slightly expensive operation. If I were going to do this every single time, I'd lose the value of interacting with the cache. So that's the first step. Now that I've done that, what I want to do is call out to the cache, grab the data, see if it's there, and if so, return it. So I'm going to create a data cache. And it's going to be constructed from the data cache factory, and it's going to be the default cache. Now what I can do is say set the products equal to the data cache get products as a string, and then I will check to see if products is not null. I'll return products. So that's the first step. So this way, we're going to check the cache. If the data is in the cache, we're going to use that and we're going to return it. Now, if it is null, what we're going to do is execute our link statement and use the Entity Framework to call it to SQL Azure, and then we want to store the results into our data cache. So I can say data cache.put products. And just to make it easier to demonstrate, what I'm going to also do is say products dot insert at index 0, a little thing that says from database. This way we can see when it's coming from the database, and then here I'm going to update it so that index 0 equals from cache. All right, did I make any mistakes?
No, that's good.
All right, go ahead and build that. I did make a mistake. All right, so what this is doing is my funky deployment method where it's zipping up all the source, dropping it into blob storage, and then all my role instances grab it out of blob storage and deploy it for me. So when I refresh, we should see it change. So we see it from database. So that's our first call. We'll go ahead and start doing refreshes. Now I have multiple instances here, so the reason why you saw it go a little bit slower the second time, it was the first time I hit the second instance. So I've got 2 instances of this web role. And you can see I'm refreshing now, and it's 5, 6, 7 milliseconds. So it's slightly slower, and even if I end up starting to generate some load, you'll end up seeing that we don't see any change in behavior. So that's the very first step. So that's using a cache aside pattern as a way of reducing the load on the database. We can take it a couple of steps further, though. And so what I want to also talk about is a concept of the local cache. So right now we're using this as a network cache where every time we do a get, a put, and so forth, we're going across the network. Now we can leverage some of the memory on our machines as well. And so what I'm going to do is configure the data cache factory to also leverage something called local cache. And when you turn on local cache, what it's going to do is it's not only going to store it in the network service cache, but it's also going to use memory on the web machine itself so that it doesn't have to traverse the network in order to get it. Additionally, since it's stored locally, we have no serialization or deserialization of our objects since it's local memory. And so it makes it that much faster to interact with it. So the very first thing I'll do is create a data cache, a local cache property. And essentially what it is you specify how many objects you want to keep in there, a new time span. In this case, we'll say keep it for 30 seconds. My invalidation policy, which right now for the caching service has to be timeout based. There's no notification policy associated with the caching service today. And so we'll create that property, and now I'm going to create a data cache factory configuration. And create that, and then on the config, I'm going to set the local cache properties equal to the properties. And then in the data cache factory, we're going to pass in the config information. All right, I think I got it all. Let's go ahead and build. Now, we should expect to see the response time even lower now, because every time we do a get, we're not going to be traversing the network, so there's no network latency, because we're going to populate the cache locally on the machine.
And this is effectively free memory on your web roles, which is anywhere lying idle that you're using.
So it's doing all its deployment magic in the background. Start refreshing. And now that I've hit each instance at least once, you can see with the refresh of the page, it's generally 0 milliseconds. And that's because we're not doing any network, we're not traversing the network, and we're not having to serialize, deserialize objects. So
you dropped it initially from 8 milliseconds
to
12
5, to 8 to 0.
To 0.
Or 12 to 5 or 6 to 0.
Excellent. And that's even with the load, the numbers don't change, unlike it would in case you were fetching data from an external store, which hits disk. So let's do a quick recap. Wade walked us through a whole bunch of nuggets there. What we just saw was we have a distributed in-memory cache, and the fact it's distributed is that regardless of which web role hits, and that was the reason why one of the web roles spiked, you always get the same data because it's a distributed cache available to multiple different clients at the same time. At the same time, the amount of time you had to go set up and get a cache to get started, this is actually the total time it will take for you to get started as opposed to opening a PO, get machines, set up a cluster, set up an endpoints. And we completely switched that to saying, just give me a cache endpoint, I can start using it. So you want to make sure that the time you spend in administrating the cache is practically zero once you have the endpoint set up. So you don't ever have to think about how do I get cache, how do I size it. And most importantly, one of the things that we did was, for those of you who've used AppFabric caching on server, all the APIs, all the constructs were identical. So some of the features are not in Cloud Cache yet, but we want to keep the APIs and the programming paradigm exactly similar. So you can take your existing application which run on server, move them to cloud, just change the endpoint, or bring them down, and the application continues to work. So you never have to think about where I'm going to deploy when you are building an application. And that's a whole symmetry promise that we have, that every service that we continue investing in, we want to make the experience on premises similar to the one that you have in the cloud as well. And that's what makes us, gives us the edge where we give you a proven code base one way or the other, and we keep investing on one to give you a symmetric experience. The second key set of benefits we saw was This is a 64-bit caching solution, so you can actually address a large number of objects. You're not really tied down with the size of the cache and the architecture of the cache service itself. It's a 64-bit architecture. And one of the things we'll get into a lot more in subsequent demos is you can dynamically increase and decrease the cache capacity. And that's very critical that because it's a distributed cache, the cache itself is never tied to the available amount of memory on any given machine. We can always bring in more machines, and transparently keep increasing the cache size. And the fact that cache is distributed in partition, you just see a virtual, extremely large cache size to continue using. And it's very, very powerful when you want to start small and grow, or if you have a application pattern which says, I don't expect to use a lot of end users hitting my website during holidays or probably in holidays. I can reduce the cache size not to pay. So keeping the cache dynamic is extremely critical to make sure that the cost model reflects your usage model. And again, the things that you deal with are purely cache config, and never worry about deployment, patching, or upgrading the cache machines. Some of the other things we saw, which were key differentiators, were there's an out-of-box ASP.NET. We'll get into some of those details in demo as well. And the extremely low latency you get when you start using local cache. That's a very unique thing that we not only have the cache tier, which you normally would, but coupled with the fact that you get this free local cache client, which you don't have to pay any extra memory for, you're just using or reusing the memory you already paid for in the web roles, and just use that to the advantage to actually get to a 0 millisecond data cache latency. That's extremely unique and high value prop for people building applications where you need to deal with a lot of data sets. More importantly, the architecture is such that you can keep any managed object. So there are no restrictions on the kind of objects you can keep. Of course, because we serialize, it goes over network. As long as the object can get serialized, you can keep it in cache. So you're not restricted to keeping key value pairs or text only. It could be rows, absolutely. It could be any objects. One of the classic example of objects we keep is session state, but you can keep images, you can keep just raw binary information, anything you want. So that's the other thing you don't have to worry about. Is cache applicable for my scenario or not? If it's managed object, it can definitely and can be serialized. It can be in cache. So the other part, and we'll dig a lot deeper, is we want to make sure that you can continue including, even though the patterns we talked about was called cache aside, where you are explicitly programming against a cache. But once you program against a cache, whether you're reading data from a local cache or from a network cache, doesn't matter. You've made the investment to fetch, store temporarily in cache, and then all the application access to the data remains consistent from that point onwards. And we'll make it easier and easier with out-of-box patterns like session state, output cache, that you don't even have to code to use cache. Config switches will help you just start using cache out of the box. The last and the most important thing is the access control token that Wade used to access his cache endpoint makes sure that no one else can read the data you have cached. So we understand that we're running in a multi-tenant cloud environment. You're really worried about what data is being kept in cache. So we make sure that we actually use every cache call gets secured by the ACS token. We keep internal mechanism to make sure that the load of checking the keys is not too high. So you still get the performance benefits, at the same time making sure that your cache data is always secure. So no other application, including any other application that you might own, unless it has that ACS token, cannot read any data from the cache. So with that, we're going to shift gears a little bit. One of the, there are a couple of different ways you can start using cache. There are a couple of different application styles that lend themselves really well to cache. And we want to quickly talk about three big ones there. The one we just saw was the reference data, where I have a product catalog or I'm reading an inventory, and I keep, it's mostly read data. It's a read-only data for most part, and you're doing a lot of reads. So it's authoritative information, which a lot of different end clients and web roles need to serve, and you just need to make it available across all nodes. And you don't typically have to worry about too many write coordination there. The second one is very activity-oriented data. A classic case is session state. You're building a game, and you want to keep the game score. You're building a shopping cart. You want to keep the shopping cart information in session state. Both heavy read and heavy write. And again, you want to make sure that because you're on sticky sessions, all reads and writes consistently go to the same data set as opposed to caching it locally but not having it available on the machine, not having to worry about read and write consistency. That's the activity-oriented data. And we'll walk through how cache lends itself extremely well even to those scenarios where you're running games, user profiles, shopping carts, and that's it. The third one, which is very interesting, is more and more, especially thanks to both data mashups, as well as just aggregating data from multiple sources, the whole notion of resource-oriented data, which is I bring in data, usually they're transacted, so you're bringing a lot of flight information from, let's say, a travel port, or you bring in stock information from stock exchanges, heavy volatile data that you don't necessarily care about every stock ticker that has to get persisted because you can keep getting the next refresh. You're looking at live data. But the data comes in at a pretty high speed and high pace that the cost and overhead of writing it to storage and reading it back to storage to serve it is extremely expensive. So very typical pattern of very frequent access, very frequent updates, but you're not necessarily writing to it. And these three patterns on their own pretty much covers a good 80 to 90% of the data access patterns that you typically would deal with. Of course, there are other cases of high-performance computing, which you have to look at different cache architectures, not the one we solve with the one we have here. But if your application falls into any one of these three big patterns, AppFabric caching just lends itself very easily for you to start including into your app today. So what we're going to do is we've already seen how we can use a reference data scenario with AppFabric caching, and we'll switch to seeing a couple more demos on how you can use AppFabric caching to use it for activity as well as for resource-oriented data. So, wait.
So one of the more common questions that I end up getting is with session state data is how to store session state across multiple instances. And so I mentioned that this app right now is running with 2 instances, and in both cases I'm using in-proc session state management. I could end up externalizing the session state to SQL Azure or to Windows Azure, and there is guidance, but neither are particularly helpful in all scenarios. In some cases, like with SQL Azure, you still need to perform some kind of additional cleanup on session state data, and same with the Windows Azure storage. And what's nice about the caching service is that it does come with the Microsoft Distributed Cache Assembly, which is a session state provider for ASP.NET applications. And so I'm going to show how to use this to not only get the benefits of having this data in memory and available to you faster, but also externalizing that session state into a single spot where all of your role instances can benefit from it. And so here's the same application, and so we're still set up so that it's running local cache. What I'm going to do is start adding items to the shopping cart, and you should notice pretty quick that the experience here is not what you'd expect. Some items disappear, some don't, sometimes they reappear. And what's happening is Windows Azure, the load balancer, does a round-robin load balance. So with each request back, I'm hitting a different instance. And the session state data in that instance is different based on where I'm at. So it's particularly evident when I come to checkout and I start refreshing this page. You're going to see I've just got all kinds of inconsistent duplicate data and so forth. And so the fact that I haven't externalized that data is particularly problematic. Now, if I come to the portal and I come back to the view cache client or view client configuration, one of the elements in here that's helpful is, let me just copy it out so it's easier to read once I get it in the config, is session state. So when I come back to my app, let's go back to web config, in the system.web, wherever it is, there it is, I'm going to insert this. What this is doing is it's a custom session state provider that's leveraging the data cache assembly that I had referenced earlier. And so I'm just going to add this so that from now on, all my applications use the caching service for their cache. So go ahead and rebuild, which is going to redeploy my application.
So in this case, you haven't written any code to access cache.
Right. And just in case anyone's curious, what it's doing, I have a post-build event that gets run and creates the zip, and then that application ends up deploying it. So that's what it's doing. Now when I come back to the application, go ahead and refresh this. Expect to see this to be different. All right, so come back here to products. All right, so now let's start adding items to the cart. Things seem a little bit more organized. I'm here to check out. And even though I'm going to be hitting different instances, you'll see that session state data stays consistent. So, I mean, that's one of the very quick value propositions of externalizing the session state data into the cache. So that's an example of activity-oriented caching. The next demo that I want to show is one that is resource-oriented. And so what I've got is kind of fun application. I don't know. What I'm going to do is I'm going to build this because this is set to use the same deploy mechanism. So I'm going to run a build here. And then what I'm going to do is run it's a simulated stock ticker application. So the web app, what it's doing is it's calling out to the cache every 750 milliseconds and saying, get me the latest ticker value for a few different stocks. And in order to generate that data, since I didn't want to really connect to a feed, I have a little app that I'm going to run even locally that's going to pretend to be a stock exchange and a feed that I'm going to be grabbing data from. I'm going to go ahead and run this. And you can see here it's just generating a whole bunch of data, and each time it generates it, it's throwing it into cache. So now when I come back to the same application we were running at before, we've got a different app deployed there now.
I want to stress on the simulated stock exchange value.
Yeah, so let's get that style sheet. All right, and so what we see here is, you see the page is just, it's just a simple MVC3 application using Razor syntax with jQuery and Ajax. And every 750 milliseconds, what it's doing is it's calling the home controller, and the home controller is set up to do a get against the caching service and get the latest values for each of these stock values. And so the idea here is that not all of the data that's getting generated are we displaying. What the app is doing is it's saying, hey, at a point in time, I need to get whatever the most fresh version of that data is and display it on the page. And so this is a case where we're generating a whole lot of data that we're inserting into the cache and then leveraging it with reads within our web application as well. So an example. Another example of this pattern is pretty soon we have a customer that's going to be using the caching service for push notifications with Windows Phone 7. And the way in which they're leveraging it is right now they're pushing so many notifications every I think 10,000 notifications every 10 seconds, and rather than writing that to disk, they're going to be pushing it into a cache and then having the push notification worker roles grabbing it from the cache and sending it along its way. So a very similar pattern here.
So the common thing is that if you can afford to not worry about transactional consistency of the data, that's the resource-oriented data, you can use cache as opposed to paying the penalty to go right to disk and read it again from the disk. So I think notification is a classic example, flight inventory, stock quotes. A lot of these are, classic example, and especially in the social world, a lot of the data, which is I keep getting a whole bunch of news feeds or a whole bunch of notifications, lends itself really well to data where the source of data and the truth is somewhere else, but you're getting a lot of feeds that you just need to consume as fast as you can and to serve it to your end clients.
Excellent.
Okay. Great. So with that, we've seen how quickly you can use AppFabric caching for any of the three typical use cases for those application patterns. So I'm going to shift gears once more and start talking about AppFabric caching release that will be available later this month. The demo Wade walked us through in the AppFabric portal today in the labs. You have only two options to pick 128 and 256 megs. When we release this end of the month, you'll have cache available everywhere from 128 megs to 4 gigs. And along a whole bunch of click stops along the way. The interesting thing is you can, of course, use mix and match multiple caches. This is the size of each named cache. You can use multiple named caches to get a larger size of cache, or you can have a mix and match of, I care about 1.5 megs, you can get a gig and a 512 meg cache. More importantly, you can start small and you can increase. And at the same time, you can start at X and you can decrease. This is very critical because if you're not sure what your capacity usage will be, your capacity planning will be, you don't necessarily have to get it right in the first shot. You can always keep increasing, decreasing. And what we've done, and that's what we spent a lot of time, since CDB releases, making sure that even though you dynamically increase and decrease, you don't lose data. So we've tried to decouple your running app from any changes you end up making on the configuration side so that it's not destructive to the data. So it's not that you decide that you want to increase your cache size, you end up causing an end user impact because all the cache data gets lost. So when you move up, of course, no data gets lost. When you move down, it causes a regular eviction. So if you go from, let's say, a gig to 512 megs, about 512 megs of data will get evicted using the same eviction policy. In this case, it's time-based or it's first in, first out, which is what your application is designed to handle. So that will also minimize the disruption of a configuration change, which you can now make independent of the actual running app. So running app just assumes the cache is available and continues assuming with the same cache endpoint and interacts with the data as if it's to the new size. So these are the sizes, and of course on the roadmap we'll have more variations of these sizes as well available. But this is what the first commercial release will be out with by end of the month. We definitely put a good footnote there. We usually get a lot of questions on what the pricing will look like. We will share pricing information when we announce a commercial launch, which is again end of the month. So hold your questions on pricing. The only thing I can assure at this point is it's a pricing that is going to be very competitive to if you were to go look at either building your own cache solution in Azure or what other alternatives in the cloud world would look like. Which brings us to the next topic. Sorry.
Actually, if I could real quick, there were two things I wanted to expand upon what you said. One thing Karan talked about was using multiple caches, and he talked about a named cache. And a named cache is a concept within the Windows Server AppFabric and Windows Azure AppFabric that's slightly different between the two. So if you recall, when I was writing this code here, I ended up using get default cache. And one thing I wanted to point out is when you're working with the Windows Azure AppFabric, you always use the default cache. And the reason is, if you take a look at this authorization information, so the token that we embedded, what this is it's a base 64 encoded string that includes in it the name of your named cache, along with your access control service token. And so what's happening is when you call to the endpoint, the caching service, it will decode it. It's able to decode it and use that name to figure out how to route to your named cache. So it's just one thing I wanted to highlight, because you're not actually going to be using like get cache and then specifying a named cache within the caching service. So that was one thing. And then I also thought it might be worthwhile to highlight and show within the portal, because I already have an existing cache, and I thought I would show you guys what the experience is to change the cache size. So the cache demo cache that I have is actually running and being used by some production sites. Well, I shouldn't say production. They're using some sites that I end up running in the Windows Azure production compute instances. And if I come here to change cache size, you can see I can end up changing it. Now, one note, the reason I'm using this existing one is you can only change the cache size once a day. And the day you create a cache, you'll have to wait till the next day to change the size. So right now, this is a 128. I can specify 256 and go ahead and set that operation. And it's going to start making those changes. Anything loaded in the cache, though, is not going to end up being evicted from it. So, which is that key point.
And none of the other configuration changes when you made that size change. So your app never needs to get recompiled, redeployed, or touched, because your endpoints, your access control tokens, everything remains the same.
Yeah. So, and I don't have to make any changes to the app. So,
thank you, Ray.
Yep.
Thanks for adding that. Actually, it's useful. So we were on the point of pricing, and one of the typical questions we keep getting on the forums and the blogs is, sure, I like the whole concept of caching. I've been working to set up my own cache cluster in Azure and manage that. And how do you compare AppFabric caching with if I was to go host it, do it myself scenario? So what we did was we put together this simple cheat sheet to think about what is it that you're really paying for in caching. So what we want to talk about is the cache is a dedicated amount of memory that you're getting. It's not about the instance memory or the VM role or the role memory that you have to deal with. It's if you get 256 megs, you can keep 256 megs of information in that cache. How we map it to the available memory on a machine at any given time, that's exactly what the cache services problem is, something that you never have to worry about. So if the OS ends up using more memory or more users start hitting, we worry about eviction, load balancing, and partitioning so that you always get the reserved amount of memory that you've asked for. So that's one big difference, that you get a predictable and a fixed amount of cache memory as opposed to worrying about instance memory size. Of course, I'm not going to talk about the ease of use. We just showed the demo, which is it takes you less than 30 seconds to get started with your own cache, versus if you were to set up your own cache clusters and manage them on an ongoing basis. The other, which is very unique thing, is the whole cache is distributed, which enables us to expand, contract on demand. more importantly, it also enables us to partition the cache so that if at any given time, one of the roles or one of the machines in the backend infrastructure was to ever go down, you never lose your entire cache. You might just lose a very, very small percent of cache, and the worst case, and that's one of the features on the roadmap, which is we just offer high availability in the cache. But that's very different than if you had only 2 instances of your server or roles running in Azure, and one of the instances was to go down, you pretty much lose 50% of your cache. So those are the design principles we factored into the design. There's not just distributed, it's heavily partitioned cache where you can increase and decrease capacity. And of course, every service we offer, we back it up with a whole bunch of SLAs. So that just gives you a quick comparison that we didn't have a production cache offering all this while, and we understand a lot of people had to roll out their own. And people who have had the experience of rolling out their own services probably can relate to the management and the administration benefits a lot better as well, because you had probably went through the pain of managing an infrastructure service that multiple users can use as well. So of course these slides will be available, but just want to show this saying yes, you can always, and I'm pretty sure that for a class of scenarios you might still want to build and host your own caching service or solution. For most cases, out of the box, you want to get started, AppFabric caching should help you address most of your needs. This brings us to the last section, and I want to leave enough time for Q&A. I saw a whole bunch of people scratching their heads in between on a couple of things we've learned in the last 2 years of shipping caching, as well as in the last 8 months of releasing cache service, on things that work well, things that don't work that well. But first and most important thing, if he ever gave you an impression that you can replace your database with cache, please, no, caching is not a database. Yes, it is a class of pattern where you had to use a database or, let's say Azure storage because there was no alternative. So, but in most cases, what you're using database for, or what you're using Azure storage for, just persisted information, cache does not replace that. That's not the goal. The goal of cache is just to accelerate, make the performance a lot better, but it's never supposed to be a replacement for the data tier. So that part I want to make extremely, extremely clear. A class of scenarios like resource-oriented data, the stock taker information, that's a good case where you don't have an option, but you're using, let's say, a database or a queue, and that's a classic case we can replace it. But for most other cases, it's complementary to your existing architecture. You insert a cache, and you get significant performance and latency benefits. So that's very, very important before you make a big design shift. The second, and I personally think is a huge benefit, is to use the local cache way demonstrated, which is the minute you start using the local cache, and all you need to do and worry about is embed the cache client in your application, and turn that config on, and you start getting a lot of benefits of no serialization, never leave the machine, still have a cache tier backing that information up so that you have a second copy of the data, and that's extremely powerful because you actually can effectively get 0 millisecond latency, which is next to impossible to get in any other network-bound or network-based caching solution. A couple of things to watch for, very critical. Today, the local cache in Azure has only a time-based expiry. If you're familiar with the server AppFabric, it has both both time and a notification-based expiry, which is if the cache item gets modified by some other client, you can get notified. That doesn't exist today in the Azure version. It's definitely on the roadmap. But it's important that you are using it for cases where time is a good way to refresh. Classic example is a product catalog, which does not get changed every 30 seconds. It's good to go refresh the data, let's say, every few minutes. Classic case where you can use local cache with time-based expiry really helps you get the performance benefits. More importantly, don't count on the local cache data always to be present. And that's the whole purpose of having a local cache versus a dedicated cache tier is you get a best effort memory allocation done to use the free memory that you've already paid for, because you're paying for compute, you're using CPU, not using memory. You can always use it as best effort, but don't design your architecture assuming that the local cache will always be there, or the item will always be there. So always assume that, worst case, you can hit the network cache. That's one general best practice to think about.
One other thing to add to a question that's asked a lot is the size of the local cache, and it won't exceed the size of the network version of the cache that you create.
Right.
So it's going to be bound, at least capped by the same size cache that you define in the caching service.
The other one, which is outside the purview of caching, but it typically lends itself to the same kind of problems that you want to solve which is serving a whole bunch of end users which are globally accessing your web application. We have two other services from available in Azure, the CDN, the Content Delivery Network, which makes sure that if you're serving static content, and large size of it, we have a huge content delivery network with lots of endpoints. So it's good to just use CDN for content delivery of the edge data access, so end users don't have to fetch large static files from let's say a data center in North America only, as an example. The other one that we announced the beta version of was the Traffic Manager. That's a pretty cool piece of technology which lets you route requests automatically depending on where your user is coming from. So if your application, if your user is in EMEA, so, I'm sitting in London, I want to hit the same endpoint, the Traffic Manager looks at where the client's coming from and will route the application request to the application deployed, let's say, in the Northern Europe data center, as opposed to trying to route the request to the North America data center all the time. So you can use Traffic Manager to significantly enhance the experience for your end users by routing the requests dynamically depending on where the end user is located at any given time. Yeah. And these are three big places where we have the data centers, and the requests can get routed. When we add more locations and places, the Traffic Manager automatically has the smarts to be able to add more routing dynamically. And nothing that you have to do specific, sign up for service, specify endpoints. Of course, you have to make sure that you have the version of the application deployed in those data centers. Otherwise, there is no endpoint to go route it to. That's very critical to get the latencies and the performance your end user are expecting in this heavily mobile and connected world. We've seen this in the demo itself, that it's really hard to solve the sticky session state problem for two reasons. The whole design architecture for a scale-out based compute platform like the cloud is that you should not make any specific assumptions on which machine will be handling a role. And the whole goal of the load balancer is that we can spray requests as fast as possible across as many nodes so that you can get the best scale-out architecture compute capabilities. It kind of has a downside, which is now, because I have no guarantee that my subsequent request will go to the same location, you need to externalize the state and yet not pay a significant performance penalty by externalizing state. And that's where caching comes really well. I mean, it's not only for session state for ASP.NET, but any shared state which multiple compute ends, or web application, or game, or whatever you're using, needs to access. It's a classic thing where instead of hitting a store, you can actually hit in-memory tier, so you still get the performance benefits without having to worry about keeping the data being read and write consistent. So we've already seen this, so I'm not going to give more examples of that one. Two other things before we switch to questions. When it is, we're very critical to do some level of capacity planning. Capacity planning is less in terms of, do I need to start with a gig or 4 gigs? That's less important. It's more important about, what am I keeping in cache? For example, it's good to just do some back-of-the-envelope calculation to say, my typical session state has n number of product items, or game state, or some other state. What is the typical size of each object and the number of users I'm expecting? So I have some sense of how much will my local cache client be able to cache? How much do I need to hit the cache tier? And how much will be offloaded always to the data tier? In the Azure Store example we took, we typically keep it's an exponential factor. For every 100 objects, you keep about 10,000 objects in memory, and then you keep about 1 million objects in 100,000 objects in a data store. That kind of helps me do a very quick math that says high probability that if I'm out of this range, I might be hitting data, the data tier itself. So it helps you build some nice techniques to reduce and get to that sub-millisecond latency experience as well further. The last one, and I can't stress enough on this point, because we've seen some cases where you deploy your web role and web application in, let's say, the Europe data center, while your cache is still in the North America data center. You kind of pretty much lose all the benefits of ever using cache. In fact, you probably pay a higher penalty because you're now going over network, paying the network price. So please, please, please make sure that you always co-locate your cache with where your application gets deployed. And with the commercial release, one of the other things is it'll be available in all data centers. So you don't have to worry about, it's only available in North America today. It'll be in all data centers. So when you pick and choose where your hosted service gets deployed to, make sure you use the same, use cache also from the same data center. That's when you'll actually get all the network benefits. Otherwise, that'll be one of your first performance issues to go to troubleshoot with. So just want to leave this slide up here, and we'll keep enhancing this. So one of the things that the team is pretty good about is we keep learning, and we keep sharing it on the forums and blogs, so you'll get that information. And I'll just give you some more pointers on where you can find more information, have a dialogue with the team. The team has been pretty aggressive in getting things out so you can serve your top scenarios. Give us feedback on what you would like to see in the roadmap, and we will make sure to prioritize those as well. So real quick, what you saw is you can quickly build extremely high performance applications, specifically web apps as well, using AppFabric caching. Some of the scenarios are just out-of-the-box config. Some you code against cache. Some you go do more advanced stuff using local cache. But in any of the cases, you get a very scalable solution that enables you to have low latency and a high throughput. Of course, we focus heavily to make sure that your administration experience is as easy as possible, so you don't ever have to worry about any infrastructure concepts. And we will also investing to make sure that it's geared towards the next generation cloud architecture, where we understand that your demand for need and capacity can go up and down, and we'll make sure the architecture is optimized to help you do that without having to make you pay more. The CDP releases, for those of you who tried it, thank you, is available for you to start using today. For those of you who haven't started and are waiting for the commercial release, it'll be available by end of the month, and we'll definitely share pricing at that point. So those two links are available to get more information, download the SDK, sign up for the free CDP release, and will be available here as well as in the booth to take questions. So we'll spend the next 5 minutes to just take questions. And thank you again.
Thank you.
So I had a question on kind of a hybrid approach. Say using the network cache with spinning up new instances, right? And then having those download to local cache. Does that make sense? Kind of thinking through it in my head, it didn't make sense, but. So in other words, product catalog, you were talking about that, right? Storing that off of the network cache, but then you'd want to get it onto the local nodes themselves. But if you were spinning up two more nodes.
Excellent. So the config setting that Wade set, which is I want to keep 10,000 objects in the local cache, as soon as you pass that information onto the web role, every time a new web role comes up, it will actually go pre-fetch 10,000, or will keep 10,000 instances automatically. The way for which object gets kept is whichever, for example, the first call, if it's fetching all, let's say 100,000 objects, it'll keep the first 10,000 objects automatically in there. Okay. So you don't even have to write extra code to prefetch, because every time a node brings up, the config says, oh, use local cache. Local cache says keep X number of objects. The first X objects or the last X objects that got fetched will automatically be there, so you don't have to worry about fetching it as well. But that's a very valid scenario.
Perfect.
Thank you.
Is there one now or a planned an asynchronous API for the cache object?
Actually, well, short answer is yes, but I want to understand, really understand your scenario. So you want to do an async update to the cache?
Yes, or a callback option where when you get a response, you're waiting for a callback to come back, so you can do like an event loop type scenario.
Fair. So we do have async APIs on the roadmap, both for server as well as for cloud. Mm-hmm. And it's good to say that you're actually looking for an event loop scenario as opposed to saying, I don't want to transact, and transact needs to be async.
Right,
so,
that's right.
That's good.
Okay.
Definitely on the roadmap. I can't promise I'm not paid enough to make roadmap statements. But
one other quick question is the protocol exposed to write your own APIs or no?
The question is the protocol exposed? Today, no, the protocol is not exposed. However, one of the things that we're investing in is we want to have a very strong interop story. So not only from ASP.NET or for .NET applications, we will provide you with one of the following ways. I don't know which one yet. Either a REST head, so you can call from any place, or we just give you libraries the way we do for, let's say, AppFabric Service Bus. We can call from PHP, we can call from Ruby. But interop is high on the list.
No socket level protocol to write our own clients?
If there is a need, we should definitely have a conversation saying if one of those two scenarios don't help you with the REST head or with the dedicated libraries, we can have that conversation for sure.
Okay, thanks.
Thank you.
Hi, is there any way to hook up a cache dependency with this?
Cache dependency?
Yeah, so that I could have one level of cache with my objects, and then I also want to use this for my output cache, but when the objects are kicked out of cache, I want to kick out the output cache as well. like a regular, ASP.NET cache dependency. Obviously, notifications would help that,
Right.
but
Actually, you're right. Notifications is what we use today to implement server. One of the other things, and it's a little bit more expensive option to do it today, is you can have two caches.
yeah.
One you use only for, let's say, output caching. So you have more dedicated experience in SLA around what will be in my output cache. And you use a much smaller cache or a larger cache for keeping things like catalog. So the short-term workaround will be you have two different caches in the same application.
That doesn't solve the problem.
But you want to see when one object is expires or
Yes.
evicted, have something that's tied to it also
I have a
evicted.
client
So-
live blogging, and they want to have it so that as
Okay.
soon as I have my thing,
Got
it
it.
kicks out of the output cache and rebuilds.
Yeah.
Got it.
So
Do we have
that's-
notifications? Yeah.
Other than notifications, I've not seen discussion of
when's
roadmap.
that?
This is the first time I've heard a request for it, so I've made a note. It's
Right.
So when are notifications coming?
I'm sorry.
When are notifications coming in the pipeline? Can you elucidate that a little bit? Like, is this a year from now or a few months from now?
So the good thing is in the cloud world, nothing is a year out usually. It's a lot lesser.
Hope not.
I can't make a statement of whether it's 3 months or 6 months because I don't think we have a book plan on
Okay.
whether we do the interop investments first or whether this is notifications high on the priority list, so definitely will happen. The good thing is notification already exists on server, so just making that scenario work really well in
Yeah.
cloud. So definitely on the near-term roadmap.
I have one other question.
Yeah.
Just in terms of performance, like if I had an object sitting in blob storage and I deserialize that to local, is that going to be about the same performance on that as it would with cache? Obviously, cache has all these other things, but in terms of the serialization and network cost, is it comparable to sitting in blob storage?
So if it's a scenario of single user connecting to blob, the numbers will look very similar. You will see a slightly higher number only because you're reading from disk as opposed to memory. So there's definitely that difference. But more importantly, what you get with cache is if you have multiple users, you'll see a significant performance difference in the network cost on the network
Okay.
latency if you were hitting a disk store.
Okay.
That's where multi-user, any load scenario, cache will outperform any data store in that manner.
Okay.
But single scenario, if you just go do one user, you'll see similar numbers, but that's kind of misleading. Good question.
Yeah, trying to understand your shopping cart example a little bit better. Are you saying that that session state could be lost? For example, you're storing it in cache, so it's not high available, like you're saying. So it could just be lost, and that unlucky user could just lose their card.
Yeah, that is possible.
Okay.
Absolutely.
If that's the case, is there any kind of patterns for when you do need apps persistent storage? Like, so let's say there's a concept of an open document or something like that, some type of open state where it needs to be persisted. How do you know?
Two things come to mind that we've talked. One, Karan talked about high availability. So with high availability in the caching service, providing a durable store for it, that certainly helps in a scenario like this. One other thought is, and one of the requests that we get asked a lot is write behind scenarios, where when I update the cache, it also writes back to a database. So it's write behind. And that is something that I believe is on roadmap. Again, in terms of prioritization, I'm not sure where it stands.
Actually, both of them are on the roadmap, which is we just give you a config switch that says turn on high availability for my cache, where we kind of guarantee that 99.9995%.
Yeah, whatever the SLA
nothing
is.
gets lost as an example. And what we'll do is we'll not just replicate, we'll replicate and have a secondary copy as well. So that will make sure that most cases it doesn't get solved, doesn't get lost. The other one is the whole write behind, where you can plug in your own query to go update let's say a SQL store or a blob store. You can plug in their own provider.
It seems like unclear, but we probably can't implement that today on our own, even if we use like a message queue or something like that and try to create our own type of transaction.
Correct.
It still seems a little impossible.
It's actually, what you do, and most people what they do today is they do an asynchronous write, so everything gets written to cache, and then they actually have an update to store procedure that gets called as well, which is just the probability of you losing the data when it's written to cache and when async method is writing to a store is so small that most people just are happy with that SLA, which is asynchronously keep writing to a persistent store.
I see.
That will work today, yes.
So kind of a background thread type of thing, and then we...
Exactly. We just keep fetching data and providing it to the store. Thank you.
Hi, are tags and regions on the roadmap, or are they going to be available
Right.
immediately?
Actually, let me make a more blanket statement about roadmap because I have a lot of questions. Anyone who's familiar with server AppFabric caching is, our goal is to have as close to 100% symmetry between server and cloud. So a lot of the features, if you are used to using a server AppFabric, will just show up. It's a question of how we sequence things, but definitely tags, notifications, regions, high availability, right behind, they're all on the roadmap. So. Thank you. That's a good question. So I don't know how we're doing on time. I know we're 4 minutes over.
We're over, so
Okay.
if you guys have any other questions, feel free to come up.
We'll be at the booth,
Yeah,
the comments.
in the
So